To share with you some of the possibilities for project work at the Eco Center, I'm going to use this blackboard that really represents a brainstorm. We'll do this a lot in the course where we're working together to try and frame the possibilities and some ideas, and then recraft this into a finer presentation, some images we can use for learning and for sharing with others. I'm going to start from the center. There are 4 basic elements associated with this facility: the design, construction, operation, and maintenance. Because we're concerned with the life cycle performance of the building, we're going to cover everything, and there are learning opportunities throughout any of these areas. Beginning with the design, these are systems you've already seen. We have solar photovoltaics, rainwater harvesting, on-site wastewater treatment, and in-floor hydronic heat in here. Those are existing systems. Being able to describe and characterize how they work will be important for our learning tools that are going to be over here. But there are also some other technologies where we could use some help framing the design choices that we're making. We're going to be getting a biodiesel generator to help back up the solar system when we have cloudy days. We're looking at installing a wind turbine to help complement the solar on days when there may be wind but not enough solar energy. And then we're also installing a solar thermal system for providing domestic hot water and for heating the space indoors. For those of you interested in doing analysis at the design scale, trying to find out what is the best option and why should we choose one and not choose others, that's worthwhile learning. There are also some design solutions that have to do less with specific technologies, but more with design spaces. We have a kitchen area right over here that needs to be built out. A sink needs to be put in and some cabinetry. Likewise, there's some workstations and also some landscape outside. These represent opportunities to try and develop design solutions that are more holistic and less geared towards specific technologies. So there are opportunities on both sides of the design issue. Once the building is designed, there are some construction issues. And for those of you who are working in the trades and are doing drawing work, I'll focus on this quadrant. We could use some as-built drawings for the way this building was built. A little bit different than the design drawings that we have right now. So doing takeoffs, actual measurements, noting the things that were done specifically with respect to electrical and plumbing systems, full plumbing and electrical drawings would be very helpful for us. Both line drawings, 2D, and for those of you who are doing 3D CAD modeling, it'd be very helpful to be able to illustrate how some of these systems work by having 3D CAD models, ranging from individual locations of pipes that are part of, let's say, the wastewater treatment system, to placing this building on the site and doing a 3D model of the topography of Heron's Head Point. Especially worthwhile for that discussion about the way this building works relative to the way nature works outside. For those of you who wanted to take it to the next level, I think there's going to be a future opportunity in the trades for people who can not just draw the systems as they are, but also reconsider those drawings in terms of the thermal, visual, acoustic, and olfactory environment. How do these systems work together? For example, the thermal environment. It's not just a matter of using solar energy to provide heat for the space. There are also windows that are positioned to harvest some of the sun's energy, and also a thermal envelope system that defines thermal comfort in here. Preparing drawings and illustrations that talk about how they work together is going to be increasingly a part of visual and graphic presentation for clients. Also, there are opportunities, just like here on the design solution side, to look at how these work together to create process environments, things we do inside the building. Personal hygiene environments, food preparation in the kitchen, learning environments like this particular room. How do these all work together to make this space work or not work in some cases? Also, there will be some very practical construction opportunities. If there are tradespeople that are interested in repairing doors, tightening the thermal envelope, taking care of some deficiencies in the original construction, we can create opportunities for you to work with us in that realm. Moving from construction into the actual operation of the building, let's call it the software of the way this building works, the behavior side. For someone who's interested in working with us on the notion of playing out inside this facility the same principle that applies to going camping in parkland, which is you leave behind only footprints. You carry everything in and you carry everything out. How might that play itself out so that this really is a zero net material resource facility where we're not generating any waste at all? We think there's a great opportunity to try and structure retreat opportunities out here that are zero net carbon. And it has to do not just with the facility here, but the way people come to and from here, using mass transit or not, trying to avoid having people park their cars, trying to create opportunities for people to park their bicycles outside so it can be seen for security, but then still rode in and out of here. Lots of small details. Also, managing the supply, storage, and demand systems. As we noted before, we have solar energy that's being collected here, but it has to be stored. And if we don't have enough solar energy, we have to scale back the demand. How do you match the demand to the supply, and how can we use storage or shifting of loads to accommodate the available storage to do the job? And this applies not just with respect to electrical systems, but to our water resource system as well. And in the end, operation is really entirely about how do these systems really work? Not just on paper, or not just in the promotional material we get from manufacturers of various products. How do they really work? That's the greatest value added the Eco Center has to provide to students, the public, policymakers, and building professionals. We're going to try and develop stories that characterize this using on-site tools where people can see how they really work, and also online tools so people can log on and see how this building really performs. There are few opportunities to do that transparently because most buildings are privately owned. This is a public space. We want to try and use you to work with us to help create ways to tell that story. Lastly, the systems need to be taken care of. From rudimentary self-help procedures, a maintenance program. How can we keep this place clean and have the volunteers come in here and have a fairly straightforward set of guidelines to use? And also for those of you who are into green materials, what chemicals should we and should we not be using in order to really make this an exemplar of the best way to get green clean maintenance practices in this building? This typically has to do with a lot of the technologies. This typically has to do with people, and it really frames the key opportunity here, which is what is the role of technology versus behavior in trying to create a more sustainable future in order to be resourceful with respect to water, energy, and material resources. That really is an issue of public policy. Behavior issue manifests itself as public policy because public policy is really saying how should we all behave. Trying to frame those opportunities is a key part of what's going on here. And for those of you who have a public policy bent and want to explore those kinds of issues, there are a number of opportunities. For example, we're plumb to use rainwater for flushing the water closets, but right now, public policy in the San Francisco Bay Area constrains us. They would like to explore the possibility for doing that and frame what the issues and opportunities are. This involves a mix of public health issues and technology opportunities. We can bring the manufacturer and the public policy makers to the table to help frame these issues. If anyone wants to work on this, there's a similar issue on harvesting gray water. Does it make sense to harvest gray water here when we have our own waste treatment system on board? And at a very broad issue, developing materials that compare and contrast central versus localized infrastructure. Here we have our on-site wastewater treatment system behind me. Where does that make sense, and where does it make sense to have sewers and a central waste treatment plant? That is fresh material that's at the heart of the sustainability movement right now. For those of you who are interested in dealing with larger public policy issues, these are great opportunities. Lastly, this is all playing itself out in the form of learning tools where we can characterize for people how these systems work so they can understand how they work and how they don't work. And recharacterize not just individual systems, not just the rainwater harvesting and the wastewater treatment, but characterizing them as a total water resource system. Not just solar energy and plug loads, but a total energy resource system. Not just trying to reduce waste, but trying to think about the materials we bring in that we use as consumables on a day-to-day basis for the learning and educational work here. Trying to frame how these can be characterized and thought about holistically could be a great learning opportunity for those of you who are going into education or think about trying to create ways for others to understand how systems work. And then setting these up so people can learn both on-site here at the Eco Center and online, so they can log on a cloudy day and say, well, how much energy is being produced over there? How much water is being consumed? And really try and create those kinds of resources. For those of you who have a bent toward online learning and computer-based learning tools and applications, there are opportunities for you here. And lastly, almost, is looking at illustrating the common principles between what is going on in the natural outside and the built environment here. There are great opportunities to use the Eco Center as a learning tool for, let's say, K through 12 kids who are trying to learn rudimentary science and math. So there are opportunities to try and use this facility to teach those principles and to illustrate them. So for those of you who have a bent more towards science and math, there are opportunities here as well. In the end, what we're really trying to do here is trying to show people how they can make better choices, because sustainability is entirely about making the best choice, the optimum choice, that which is best suited for the particular circumstance of the building and its social setting, its environmental setting, its political setting, the economic setting. Optimum choices are critical. To help frame what those are here will be a great exercise for you. And lastly, what we're really trying to do is not just talk about sustainability, but talk about realizing performance, realizing the reduction in material consumption, realizing the optimization of the use of those resources so we get as much as we can out of them. You can help us by pursuing any of a variety of these options. There is a big umbrella here. There's a lot of room for people underneath it, and really opportunities, as you might see, to work together and collaborate. That alone will be a worthwhile credential for your future professional portfolio.